brief video that introduced the logistics of ACE 451 power system analysis. So we're going to go over the grading policy and the class material for the semester. The textbook we will use in this course is the Granger's book. This is because I like the notation used in this book. I think it's more rigorous. You can also refer to the Syllabus book. I think that book is pretty good as well. It includes a lot of MATLAB examples for solving different kind of power system problems. Regarding the grading policy for this course, homework is worth 20% of the total grade. It's 20 points in total. So there are 12 homeworks, each worth 2 points. We sum up all the 12 homeworks, and then that will be your total final grade. If it exceeds 20 points, it will be capped at 20. A homework solution, I have gave that to you, but the web work uses a random generator to order the inputs. So each one of you will get a different answer. The solution will have an answer, but it may not be the same for that. There are 2 exams in the semester. Each will worth 7.5 points. Again, the solution is given to you, so you can take a look at how the problems are solved. But the web work will alter the inputs, so each one of you will get a different answer. The class project has 3 sections. It worth 25 points total. I'll give you an example later on for how the class project will be arranged. The in-class quizzes, there will be one after each lecture. Gave you either an hour to fill that or until the midnight of the same day. I am still working on that and then see which one works better. The final exam is 25 points. It will be Moodle based. All the in-class quizzes and final exams are multiple choice questions. It is on Moodle, so you select that, and then you will see that in the in-class quiz, there will only be 3 problems, and then they are common sense questions. It won't require you to do calculation. But in final exams, these multiple questions, choice questions will require you to do computation. For each quiz is 0.25 points. There will be about 25 quizzes. So when you add them up, if you hit 5 points, you are good because it's capped at 5 points. So the remaining quizzes, if you want to take it, you can take it. If you don't, that will be fine. For the software used in this class, it is MATLAB. We're going to use it extensively throughout the semester. Here's a little bit more details regarding the exams and the quizzes. The 2 exams will be conducted in class. You have 1.5 hours to complete them. It is web work based, so it allows a limited number of submissions. It will give you feedback instantaneously, so you know your answer is correct or not. You can try multiple times. You are not going to lose point for that. You can either use MATLAB or Python to compute the results. So if you have some scripts ready before the exam, you can just take them and then run it. It should make the exam a little bit easier. The in-class quizzes, like I said, they are common sense questions. They are multiple choices, and then it should only require you to take a few seconds to answer them if you know the answer. Here's an example for the previous class project assignment. This is just to give you a flavor how the class project what the class project will look like. The first part is to model a small residential neighborhood. I gave you the end-use load consumption for each household in this neighborhood. For example, I gave you 10 load profiles, each representing the minute by minute energy consumption for these households. and then I'll let you add them up, and then to select a PV that can supply this neighborhood. The second assignment could be power flow computing. So it gave you the 3-bus system and then let you compute how the power is flowing from one area to another area. The third assignment would be you have a group of generators here. You are going to decide how much each generator is going to generate to supply the load. So the point distribution is the first part of the assignment usually is 7 points, the second part is 8, and then the last part is 10 points. In the past, a lot of students ask me, Dr. Liu, how am I going to get a good grade? First of all, you want to attend the lectures, attend each of them. If you do miss one, you can watch the recorded lectures. In the past few years, we do record all the lectures, but if you are relying on watching lectures instead of coming to the class, you are going to have a hard time to keep up because sometimes you skip a few lectures and suddenly you find you can't understand the class material, and then that would be too late. And second, form a study team. I found in the past the students in a study group tends to do really well. That's because you can have friends to discuss the problems you don't understand, and then you can have a multiple angle when you handle projects. Regarding the white work-based homework and quizzes, we already have solutions posted. So you want to get full points in these two parts of the assignments. And then for in-class quizzes, complete all of them to get that 5 points. And for the project and the final exams, though, these we don't have standard solutions. So you want to work hard to see if you can get a comprehensive understanding of the class. But if you participate in all the in-class quizzes, you should do well in the final exam as well. It is a test for how much you know about this area. In Module 1, we learned to build the models for major power grid components. As shown in the figure, there are 4 major components. From left to right, we can see there are generators for generating electricity, there are transmission lines for carrying the electrons from the generators to the loads, and then there are transformers for boosting the voltage up from 12 kV to 400 kV. And then there are step-down transformers to step voltage from 13 kV to 240 volts, where we can use to power our appliances. We also learned to do a few computation. First is computing the complex power, the P and Q, and then we learn how to regulate frequency so that we can match the real power variations. Those are mainly generation control. And then we want to know how to regulate the voltage, and then that will be mainly related with the reactive power compensation. And then we will learn why we need to use per unit computing. This is mainly to get rid of the many different voltage levels. If we use a per unit value, then we can view all the voltage as 1.0, and then at each voltage level, you use the base voltage to convert the per unit value back to the actual value. So we're also going to learn why 3-phase circuits can be simplified to 1-phase circuit, and then how we're going to simplify the device model so we can use the lambda model to represent the transmission lines, transformers, and generators. So in the second module, we learn how to operate power systems. So the module has about 10 to 11 lectures. First, we want to know how to compute power flow. That means given there are 3 generators, how we can send power from generator 1 to 2 or to 3. If the generator each has a cost associated with that, then during the course of a day, at each hour, which generator needs to generate how much so we can supply the load at the minimum cost. That would be how we do optimization. So you won't learn really complicated optimization methods, but we'll use simplified algorithms for you to learn how we can schedule the generators a day ahead for each hour. And then when each hour comes, when the load starts to vary, how we are going to use economic dispatch to send this difference to each generator so we can meet the real-time variation of the load. This is to teach you how to be an operator of the grid. In this case, the minimize the cost and considering whether or not the transmission line will be overloaded is the main concern. And then we also want to minimize the losses. The third module, we will learn how to compute power system fault. There are about 8 lectures in this module. We'll learn how to compute the short circuit current. So based on the short circuit current, we can select the equipment. For example, how we should select the breakers so that it will sustain the fault current. And then how we select transformers so the overload current will not damage it. We also will compute not only the three-phase symmetrical fault, but we also compute the fault current for unsymmetrical fault. For example, there's only one line is grounded and the other two is not. So in this situation, we will not only need to use our regular way to assume the three phases balance to compute using one phase representation for three phase. We need to use a different advanced method to compute the positive, negative, and zero sequence current, and then combine them together to compute for the unsymmetrical fault. So for this module, our goal is to learn how to estimate the power system operation in the faulty conditions. And then that condition will help us to define when the system fails, what is the stress level for each component. And then we can decide how to set up the protection relay to protect the system equipment from damaged. And then we can select equipment accordingly. So this is also a very important module. This shows the exam schedule. For quiz 1, it covers the materials we learned in module 1. And then for quiz 2, it covers the admittance matrix and power flow. And then the class project basically is covering the economic dispatch and unit commitment. For the fault and some of these quiz 1 and quiz 2 materials is going to be covered by the final exam.